Daya, Darshini, and Adarshini. Am I audible?
Yes, sir.
Okay, listen. Only you three have joined, and I don't have anyone here. Okay, but as I discussed, I wanted to start the alternating current chapter. Adarshini and Darshini, can you tell me when is your exam? Do you have an exam on Thursday?
Yes, sir.
Yes, sir. Chemistry exam.
Chemistry, yeah? So will you be joining the class tomorrow?
Yes, sir.
Yes,
But you
sir.
join. If I take class tomorrow, you're going to join. Am I right?
Yes, sir.
Yes, sir.
Okay. So what about Laya? When is your exam getting over? I don't have anyone here.
Our exam gets over on Friday. On Friday.
Do you have any exam on Thursday?
No. Today we had a physics exam.
Mm-hmm.
Today we had a physics exam.
Yeah, I got it. I got it. Yeah.
And next exam is on Friday. That's the last exam.
Next exam is on Friday.
Yeah.
Okay. So I'll do one thing. Maybe I'll wait for 5 to what is the time? 4, 6, right? Maybe I'll wait for 10 more minutes maximum. Let me see if anybody is coming here. We'll start off with the alternating current chapter. Else, I'm going to start it tomorrow. And listen to this carefully. I'm going to send a circular stating that no more cancellation of classes will take place irrespective of exams. Is the point clear? So I'm not going to cancel any more classes. If you have exams or anything, I'm going to send a circular officially because we have so many portions, so many chapters to complete in the first place. Clear? So if today I'm not able to start, from tomorrow I'll be starting off with alternating currents. Okay. So just as I mentioned, give me 10 minutes of time. Let's see. Just waiting. Okay. Students will be starting in the next 2 minutes. Okay.
Yes, sir.
Yeah. No problem. Yeah. See, those are online. Am I audible? Is my voice clear?
Yes, sir.
Yes, sir.
Okay. So listen, I just want to give you important updates. Okay, we'll be getting an official circular also, but I wanted to tell it, and then I want. See, yeah. Are you all able to see? Those are online. Are you able to see the screen? I've shared one Google Docs, I mean Google Sheet. Are you able to see that? I'll explain
Yes.
what it is, don't worry. Yeah. So listen to this carefully. Going forward, okay? Going forward, since we have more chapters to complete, okay, and less time, I'm not going to cancel any of the classes, okay? Irrespective of whether you have school exam, even if 1 or 2 members are going to attend the class, I'm going to conduct it. If at all you miss the class, right? The thing is, we'll give you the pre-recorded videos of it. You have to make sure that you're going through it because I know what is going to happen in the last minute. Trust me, for these half yearly or whatever exams you call itself, look at the pressure you have. Imagine boards. If I'm going to rush, you will be under struggle. So I'm not going to do that. I can only teach 3 to 4 subtopics a day. You see my speed itself is I'll not go more than 3 subtopics a day. 3 subtopics along with problems, right? So I'm not going to cancel any of the classes going forward. And for that, you will be getting a schedule in the month starting itself. So let's say we have not shared it for this month, but we have already prepared. You will be getting it today. Okay. So this is starting from today. Okay. This is for this month. So you have 12 classes in a month, right? So I have segregated how those 12 classes are going to be planned. If you observe clearly, the first class was on 4/9, which was a Monday. I was supposed to start with chapter. Actually, there is a mistake with the number. Don't worry about it. I was supposed to start with chapter 7. That was a plan in my mind. But chapter 6, electromagnetic induction, mutual inductance, and mutual inductance of 2 solenoids were discussed on that day. I handled the class, so my name is there. Like this, if you observe, right, this orange color part is there. No, this orange color part is for the substitute teacher. If at all I'm not available on a particular day, I'm going to put a substitute teacher for which it is going to be an online class. I hope you would have attended this section. So it is about electromagnetic induction, and I've asked teacher to solve the miscellaneous problems. So that day, others held the class. Apart from that, you have holidays and all, right? So for example, Wednesday, you remember it was a holiday. I'll give a different color. This color will be given there. So you'll get the complete list of when you have holidays, what assignments will be given in that particular month, what subtopics I'm going to deal with, and who's the teacher who will be handling the class, or if you have any tests on particular day. So if you observe the sheet, right, we are on which date? We are on 19th. So we are here. So we are on this date. 1 minute. We are on this date. So if you observe, I had a plan of starting alternating current, but see, because of last week's confusion, I had put this because I didn't release it. I put that no class due to ongoing school exam. So I don't know when your schedule is. So for this part alone, to ensure that you and we are in sync, we will have one of the representatives from one school. For example, this batch consists of 2 schools, DAV and Sunshine, right? So I'll need one of you to be volunteer and give us your school test schedule 1 month in advance. How many days before you get? At least 15 days in advance. Only a week or something. Okay, if that comes, we need to be informed. Because for generally for DAV, I think they announced it. DAV, when did you get it? At least 15, 20 days in advance, you got it, right? Are you guys there?
Yes, sir.
Those who are from DAV, are you guys there?
Sir, we got it
Yes.
in the starting of the year itself.
Sorry?
We got it starting of the academic year itself. We got the
Oh, you
schedule.
got the starting of, see, for them, yeah, there is a academic year plan itself. It is installed in the diary itself. So if somebody, I will take it from you in a month in advance. I'll put the schedule like this and give it to you so that there is going to be no confusion for you guys. Okay, this is one kind of support we'll do from our end. Secondly, see, I could see there is a mismatch in the way the syllabus is being handled in your school and DAV. See, it happens. When it comes to a common forum, right? That is a problem that always exists, but we have a solution for it. I'll tell you how we are going to support you. For that, the first thing is, if you see for DAV, they are lagging a lot. They're in 4th chapter or something. We are in 7th chapter. I was supposed to start. But you people, it is going haphazard. They started with 10th chapter, then they came to the 1st chapter, again 12th chapter. So that is not the way to learn it, because there is a reason why the syllabus is organized. At least I'm not talking about, okay, for all the subjects, in fact, the syllabus is arranged in that way for a reason. If you see, I cannot teach inverse trigonometric functions and then teach you relations and functions. I'm just giving an example of math. Because inverse trigonometric functions, the name itself has functions. Without me teaching you what is function, I cannot teach you relations. I cannot teach you inverse trigonometric function. That is injustice. In a similar way, ray optics, if you see the first line itself that is given is light is an electromagnetic wave. I need to explain what an electromagnetic wave. For that, you need to learn all the 8 chapters. That is the reason I go in the order. Okay, so that you have clarity of what you're doing. But I cannot control the system, right? So your schools have a different schedule. I'm no one to comment, or you have no power on it. So what we can do is, as a part of coming together, one thing to help you with the exam is we'll give you the pre-recorded videos, because everything is available. Like for example, one of your school students, I think Laya, approached me for wave optics chapter. If you see for wave optics, I've already given pre-recorded videos. Now I'm going to tell you how to make use of it. So the pre-recorded videos are supposed to be made use even during the time of your exam. Let's say there is a mismatch in the portions that we are dealing and the one that is there in school, you can always keep us informed. So you need not get scared, or you need not worry saying that sir is going to say something, he's going to scold, nothing of that sort. We are here only to support you. So we are always approachable. Either me or, see, if you don't get time to talk to me, you can always keep a staff or someone informed so that the news will come to me. They already know what is the procedure of giving you the pre-recorded content. Now I'm going to explain you how the pre-recorded content will be given to you. Okay. So just give me a minute. And how to make use of it. Right. So you all have the app, right? You all have installed the app. Everybody. So I didn't see anybody without an app, but okay. Let's say, see, this is an admin access. You will not have access to it. Okay, I'm going to show you here, but the same thing is applicable on the mobile phone or tablet. So this is the access. See, for example, if we go to your batch, yours is 12th Physics B1 23 24. Those are online. Are you able to see my screen? Yeah?
Yes, sir.
Okay, listen. So we are tracking your attendance here. So you put the sign and everything here, right? Your attendance gets tracked here. See, for example, 12th, we had a class. We'll know who all were present and who all were absent. So this is how we get update. I'm just showing you so that you should understand that we do track it. Okay. And assignments part, of course, you know already. So assignments, you have to upload it here and we track. See here, we get the status like this, 0 out of 18. So I go inside and see, I'll get the complete data of who all have submitted, who all have not submitted. The most important part is videos. I told you, right? We'll be supporting you with the videos. So for that, what we are going to do is, sometimes there is a mismatch. 1 minute. Now, so when you go to the videos, there are 3 folders. Did you see this? So one is the live class recordings. The meaning of live class recording, the one that I'm speaking now, will be uploaded. You have the Zoom recordings, right? Without me appearing, the screen recordings will come there. That is the first thing. Second thing is about the pre-recorded versions. So pre-recorded means in this live class recordings, you would have seen that I'm recording the videos, right? These videos will later get edited, and I'm actually creating a repository for your boards. Okay, live class recordings is to provide instant support, because in previous class you would have not heard something properly. There would have been some doubts or something before exam. You need revision. Everything will be available, but it will be a continuous lecture that you already know, right? So live class recordings are going to be like this. See, for example, chapter 6, we have already given the. It will be broken like this, lecture 1. So totally, I took 8 classes of this to complete it. In those 8 classes, I put on which day what topic was covered, AC, eddy currents. See, spelling mistakes and all, don't ignore it. Okay. For someone else is doing who doesn't know the subject, they are uploading it. Okay. So this is there. No? So this is 1 hour of lecture, but you have to just move it and see so that the screen recording will be available. So we have tried to avoid the voice issues. We had voice issues before it, but I don't think you have it now. Right. And when it comes to last week, if you see, I would have sent a Google form asking you what are all the revision topics you need. See, revision topics, I'm okay to support and reteach, provided there is no support, like you don't have any other source, right? So what I'm suggesting is we already have this content called as pre-recorded. Like I told you, right? Wave optics, somebody asked me for help. So you go here, you filter it according to name. So it will come in the order itself. Let's say tomorrow, like 1 week down the line, you have wave optics, but you didn't understand something from your school. You can always go here and watch the lecture. So here itself, if you observe, so everything is broken. If you see, it is not 1 minute, 1 hour lecture. It is actually 9 minutes, 3 minutes, 2 minutes, 6 minutes. It is properly edited version. So the edited version is already put here, so that whichever subtopic you have doubt, you can always go and have a look. Apart from that, if you have any doubt, you can reach out to us on the student support. Okay. Am I clear with this? Because when I sent the Google form, most of them asked me the first 3 chapters as revision. So if you observe, the first 3 chapters have already this I recorded during COVID itself. If you see, it is already broken in terms of small chunks. So there are 33 lectures for it, for which you can always go through it. See, for example, before I explain torque experience by dipole based on uniform magnetic field, I actually explained what is torque from your 11th standard also, because I know most of you will not remember what is torque. So there will be topics touched from the 11th standard also, so that it is in a proper sequence. Okay, it is like a storyboard only. You can go in that particular order to have a look at it. So what I'm suggesting is, whenever I ask you for revision classes, please don't ask me for the first 3 chapters, because the first 3 chapters I've already taught the deleted portions also. In the sense, if you go to theory lectures, so there are topics like potentiometer, carbon resistors. I've explained about the color code. Everything is there. Everything. Literally, your NCRT is converted into video format, where I only explained everything. So you can have a look at it. Okay. So in the same way, what I'm going to do going forward is, if at all, let's say you're not able to attend a particular session for some reason. Okay. As I told you, from my side, there will be no cancellation unless I'm unwell or something. Even if I'm unwell, I'll try to arrange for a substitute teacher and close it. Okay. But we'll ensure that you are on track with the syllabus. So this is the kind of format you will get. Now, additionally, what I'll be doing is I'll be sharing a Google Sheet of which topic will have the lecture at which particular place. I'll show you that part also. Okay. Just a minute. Just a minute, I'll be back.
So you're not audible.
Yeah. So your Google responses are going to come in this format. And if you can see here, there are certain names, right? So Nivedita, she's a student from our 11th standard and she's from DAV Public School. When she entered the revision topics for physics, she told projectile motion and motion in a straight line. Okay, so what we did is we have uploaded all the videos in the app and in YouTube, depending on the feasibility of the topic. And so this is how we have shared. So she has asked me for motion in one dimension, which is going to be third chapter. So this kind of a format will be sent to you. So what are all the subtopics that are there in motion in one dimension is lecture 1 to lecture 9. So each lecture is broken. So lecture 1 speaks about the basic terminologies in one-dimensional motion. Basic 2 is only about non-uniform motion. Like this, if you read it, let's say you're preparing for some exam, you have problem with derivations of equations of motion using calculus. You can always go here, and we have mentioned which is the location in which we have put it. So these videos, since they're at the beginning of the year, we have given it in our official YouTube channel itself. In that YouTube channel, if you go and click the link, so you'll get the PDF, right? You're able to see there is a YouTube link coming down. So in the PDF itself, it will be a link format. You click on that, you'll directly go there. You can always have a look at it. Is the point clear? So in a similar way, for motion in a plane, vectors and projectile motion, this is also something she asked. So motion in a plane itself, we broke it into two subtopics, vectors and projectile motion. So this is something that was given. So like this, the lectures were broken. What is the location it is present? It is present in the Learning Room app under the pre-recorded video folders. For this, there will be no link. That is why we put it as not available, since only registered students will have access to this. So you can always go it in this format. We will share everything like this also as a consolidated report. Okay. So going forward, you need not ask us where which video is there, if it is completed or not. Okay, you need not worry about anything. All that you need to focus upon starting from now is only on your exam. How are you going to learn a particular subtopic that you don't know, or a particular chapter that you don't know? What is the practice you are going to do? That is all you need to be bothered about. So if this is sorted, right? We have taken all the stress from your side. So this is consolidated. You need not worry about how many subtopics are there also. Everything is here only. For example, electromagnetic induction, I'm going to give it like this because for 12th standard, most of them asked me for 5th and 6th chapter. Like most of the responses were first 3 chapters or 5th and 6th. Okay. So when it comes like that, I cannot reteach the topics again. So for 5th and 6th also, it will be broken in this kind of a format. For example, lecture 1, electromagnetic induction, introduction. Then you will have Faraday's law, then Lenz's law, then problems based on Lenz's law. Everything will be perfectly organized. You just go through it. Any doubt, it will be there itself. Apart from that, you have any other questions, you can always let us know. So we'll try our best to sort it as soon as possible. Is the point clear? Is that clear? So this is the reason why I'm saying I'm not going to cancel any of the sessions going forward. Okay. So having said this, any questions? Those are online, any questions? Is everything clear?
Yes, sir.
Okay. So next week, if you see, right, I have put 2 topics. No, there is a test on fifth chapters. Would have seen that, right, in red color. That is magnetism and matter. That is on Monday. And Tuesday is going to be a study holiday. And on Wednesday, you'll have a test in electromagnetic induction. But since I'm giving you very less notice, what I've done is I'm going to ask you only derivations and definitions. So you need to go through them because it's going to be 1 hour test. You're going to write it during the school hours. I mean, during the time you're going to come. Am I clear with that? Okay. So I hope those who are online understood how to make use of the report that we are going to send. Am I right? Is my understanding right?
Yes, sir.
Okay. So it is your responsibility to keep your friends informed about it. I'll be dropping a message. Okay. You help them if they have any questions related to it. So now we'll get started. So write down this topic. So chapter 7. Shall we get started? Right? Shall we? Yeah. So listen. So now we'll be starting with the 7th chapter, which is going to be called as the alternating currents and the electrical machines. Right? So if you look at the name of the chapter, it says alternating currents. But if you go back to the 3rd chapter and observe, right, that is also known as current electricity. So if you observe the name of chapter number 3, what is the name of it? It's called current electricity. Now comes an important question. Here also I'm using the word, sorry, here we are using the word current. And here also we are using the word current. Then why are we learning the same topic in 2 different chapters? That is the first point we need to answer. Right? Why are we learning the same topic in 2 different chapters? That is about current. So if you look at the answer for it, right, it is very simple. Question is, when you discussed or when you learnt about current electricity, the concept was all related to direct current. if you see in all the circuits that we drew, we had something like this. We had this kind of a battery, which has a positive and a negative terminal. So this is a battery, right? Series of cells, we call it as battery, and this is a DC source. It's a source which supplies direct current. But the important question that we need to ask is there a counterpart to it? The counterpart to it is going to be the alternating current. So in this chapter, in chapter number 7, we are going to understand how each device, when I say device, right, the devices are resistors, capacitors, and inductors, along with their combinations. See, till now, when we discussed about current electricity chapter, right, about the concepts in current electricity, we saw the concept of resistors in series. In second chapter, we had capacitors in series. Then in the previous chapter, we discussed about inductors, but there is a concept like inductors in series, or you can connect inductors in parallel. So individually, if you observe, second chapter was concerned only about capacitors. Third chapter concerned only about resistors. And sixth chapter, we spoke only about inductors. But in this chapter, what we are going to do is we will take the passive elements like resistors, capacitors, and inductors, and then we'll study about their combination, right? You can always ask a question, can resistor and a capacitor be connected in series? Yes, they can be. But the question is, across what source are you going to connect it? Resistor and capacitor connected across each other in series, and you connect it across a DC source. That is something like this. It will behave in a different way compared to you connecting it across an AC source. So in this chapter, we will try to understand how these combinations are going to work. But before that, we need to see how each element is going to respond to the alternating current, right? So if you observe, right, to put it very simple, the concept is, in this chapter, we are going to discuss only about alternating current. We are not going to discuss anything related to direct current. That is the first thing. Second thing is, when you talk about electrical machines, these are all the devices which make use of all the devices that I told to give out some output. For example, if you think of this fan is an electrical device. You think of the tube light, that is an electrical device, right? So all these devices where you have the resistors, capacitors, and inductors connected together to get some desired output by using the electricity, you can call them as electrical machines. I'm just giving you the simplest definition that is possible, because there are two types of machines. One is electrical and the second is electronic. If you think of electronic, right, your laptops, mobile phones, tablets, smartphones, obviously, yeah. All these things fall under electronic device because they have a completely different application, in the sense they are not designed only based on these kind of passive elements. They are designed using something called as PCB, which we call it as printed circuit board. Have you ever seen a computer being opened, a CPU opened? Whenever they repair, there will be something like green color pad inside. That green color one is called as the printed circuit board, in the sense that circuit will already get printed, and all they do is they do something called as soldering. They take a heating machine, just place it on it so that the device goes and gets stuck to that particular part, and then the electrical connectivity is established. So those kind of devices are called as electronic devices. They fall under the category of semiconductor physics, which will be the 14th chapter. So 7th chapter is about electrical devices, and the 14th chapter is about electronic devices. Okay, so this is where the engineering also gets classified. You would have heard about ECE, EEE, all these things. No, ECE stands for electronics and communication. EEE stands for electronics and electrical. So you'll be learning both. You're able to understand, but they will focus more on electrical. That's a different subject, but I hope you're able to get some perspective of it. Right. Now, having said this, the first question that we need to ask is, right. So the first question that we are going to ask is, where is this alternating current getting generated from? If you see, the beginning of this chapter is actually the end of the previous chapter. The last topic that we discussed in the 6th chapter was about an AC generator, if you remember. So that would have been the last topic, AC generator and electromagnetic induction. If you see, the output of an AC generator will look like this. E is equal to E naught sine omega t, where E naught itself is a replacement of few parameters like NBA omega. That is a part of the derivation. NBA omega was what replaced with E naught. So that is value. Now, if I look at this, this is what I call it as alternating EMF. So of course, for you to produce current, you need an input, right? So the input that you're going to give is an alternating EMF, and the output generated is going to be an alternating current. So as the name suggests, alternating current, right? We will first try to understand what exactly it is. Okay. So listen to this. An alternating current is obviously a current that has a magnitude, right, that changes continuously with time, right? Whose magnitude changes continuously with time. And not only that, its direction reverses periodically. Whereas when you talk about a direct current, it will flow with a constant magnitude in the what we see. So if you look at this diagram itself, right, there are two that are represented. So first thing that you need to observe is, listen, when I talk about an alternating current, you have something like this. You have a wave kind of structure where you call this as positive cycle and you to water. If something is above x-axis, you call it as positive. Something is below y-axis, you call it, sorry, below x-axis, you call it as negative. So this is positive half cycle. Why I call it as half cycle is because from 0 to capital be the positive half cycle, bottom part is going to be the negative half cycle. So to put it simple, alternating current is going to have these kind of cycles and direct current will not have anything of this sort. Now, right, I just want to add one more point that, right, if I draw something like this, how do I classify this as? If you observe, it has a positive cycle, and a, what can I call this kind of a current as? This is also called as direct current. So I want to do a small correction in the statement here. So they just gave you directly to differentiate what is direct current and alternating current. So direct current need not have constant magnitude always. Direct current can have varying magnitude also. If you observe, it is going up and coming down. It can have a varying magnitude. But the most important differentiating factor between alternating and direct current is how many directions the current is there. If you observe, an alternating current will have a positive cycle and a negative cycle. It reverses its direction periodically. So if I have something like this, it will be called as an alternating current. But the one which I drew here, the previous one which I drew here, is still a direct current because it is unidirectional. It has only one cycle. What is it? Positive cycle. But the only thing is, this direct current will be called as a fluctuating DC because the value of the magnitude is changing with respect to time. But what is not changing? Direction is not changing. So to put it simple, right, the simplest definition that is possible for direct current and alternating current is, alternating currents are bidirectional currents. What are they? They are bidirectional. Bi means two. They have two directions, positive and a negative direction. Whereas when you talk about a direct current, they are unidirectional. Are you able to understand? So unidirectional currents are what are called as direct currents, and bidirectional currents is going to are called as the alternating currents. Am I clear with this point? Right? So just make a quick note of it. Those are online. Am I clear?
Yes, sir.
Yes.
Okay, make a note of it. So those who are online, are you done copying? So listen to this. Now, when you talk about an alternating current, so when you talk about an alternating current, what is the mathematical expression given for it? E is equal to E naught sine omega t, right? If you observe, the EMF is expressed as a function of sine. Am I right? So it is expressed as a function of sine here. And if you look at this expression, right, this is somewhat similar to y is equal to a sine omega t, which you would have learned last year for a simple harmonic motion, right? So if I just do a small comparative study to understand this, here, what does this y stand for? Y stands for the displacement of the particle. So how much has the particle got displaced from its mean position is represented by y. If I do the comparative study, instead of y, what do I have? I have E. So this E tells me the instantaneous EMF. So what do I mean by instantaneous EMF? What is the value of EMF at a particular instant? So if I substitute different values of time into this, it will give me different values of E. For example, if I substitute 5 here, that value will be different compared to 5.2 because it's varying with respect to sine. Right? See, sine of 5 pi will be different from sine of 5.2 pi. Just an example, right? So the value of E is going to change. So what is this E called as? It's called as the, what did I say the name is? It's called as the, I'll write it here. E is equal to E naught sine omega t is there. No, this E is what is called as the instantaneous EMF. So it is called as the instantaneous EMF. Now, if I look at this expression which I wrote, the one for simple harmonic motion, A stands for amplitude. Amplitude means maximum displacement from the mean position. Right. In a similar way, instead of A, what do I have in the case of alternating current? I have E naught. So this E naught is the one which is going to represent the amplitude. So that's the first definition we are going to see. What does this amplitude stand for? Amplitude itself means maximum displacement. From where? From its mean position. But here I'm not talking about the particles displaced by the EMF. So that is why if you see the maximum value attained by alternating current in either direction is called as amplitude or peak value and is represented by the symbol I naught. So if it is going to be current, you represent it as I naught. I naught is called as the peak value of alternating current. Then what will E naught be called as? E naught is called as the peak value of the alternating EMF. So let's visualize it diagrammatically. What do I mean by the maximum value in either of the directions? Right, that is something I need to understand from this diagram. If you see, the graph is going up and then coming down. It is going to the bottommost point and again coming up. So this is the maximum displacement in the upward journey or in the positive cycle. And this is the maximum displacement in the negative cycle. So what I can say is, if I drop up here and join it, this height is E naught and this height is also E naught. I hope I'm clear with this point. The next important point we need to answer is, what is time period? Name itself is suggesting time period. So the alternating current changes its direction periodically. So it takes a certain time to come back to its positive cycle. So what is happening? From positive cycle, it is going to negative, and from negative again, it has to come back to positive. How much time does it take between two successive positive cycles or between two successive negative cycles is what is called as time period. Or to put it very simple, right? It is the time taken by the alternating current to complete one cycle. When I say one cycle, what do I mean by that? One cycle means it's a combination of one positive half cycle and one negative half cycle. The sum of these two put together, the time taken to complete this journey is what is called as time period. And of course, time period is represented by the symbol capital T. Okay. Now the next question is, how do I calculate? See, here I can calculate the time period in the case of simple harmonic motion because we'll know how much time the particle is going to take to go from extreme position and for it to complete the cycle and come back to the mean position. We can do that using a stopwatch. But here, how are you going to calculate the time period? For that, we should know how much time. So who's producing this alternating current? First of all, the question is who's producing it? It is the AC generator. So when you look at the AC generator, you have an armature coil which is rotating. So it is the one which is rotating with an angular speed of omega. Am I right? So the time is equal to the time period. The time is equal to the time taken by that coil. Which coil? The armature coil to complete one full rotation. So the time taken by the armature coil to complete one full rotation is going to give us the time period of this alternating current, because the time period of this is decided by the coil, not by anyone else. Okay. So if I say that the angular velocity of the coil is going to be omega, then what is time period going to be equal to? Time period is equal to, so we know that time is equal to distance by speed. Whereas when it comes to rotation, distance should be replaced with angular displacement. So time period is equal to angular displacement divided by angular velocity. So for it to complete one full rotation, what is the radian it is supposed to cover? When a coil rotates through one full rotation, what is the radian? 360 degree is equal to 2 pi radian. So it covers 2 pi radians. And with what velocity? It covers it with an angular velocity of omega. That is why this 2 pi by omega is what is called as the time period of this particular alternating current. So can we just conclude it? Who decides the time period of an alternating current? It is a coil. The time taken by the coil to complete one full rotation is going to be the time period of the alternating current that is getting generated here. So first make a note of this one. Am I clear with this? So let me know once you're done copying it. Done? Now listen to this. Now, the last parameter that is associated with an alternating EMF is going to be frequency. So we know that E is equal to E naught sine of omega into T, but we also know that E naught sine of omega can be written as, we have seen this in the previous chapter itself, 2 pi f into T, or this can also be written as E naught sine of 2 pi by capital T into T also. It can be written like this, where here small f represents frequency, capital T represents time period, which we saw in the previous case, and omega represents the angular frequency. Right now, what we are going to see is about this small f. What is it called? It's called as the frequency. There is no prefix or suffix to it. It is just frequency. Right? So what does frequency mean? Frequency means how frequent something is going to repeat itself. Right? So it clearly says the number of cycles completed per second. So if you see, if I take this kind of a wave, this is positive, negative, positive, negative. If you observe this, how many cycles are completed? 2 cycles are completed. But I didn't put a question of how much time did it take for the 2 cycles to get completed. Suppose I put a question like this. These 2 cycles are completed in 2 seconds. Then what is going to be the frequency? It will be 1. Because what does the frequency definition tell you? The number of cycles the alternating EMF is going to complete in 1 second. What did I tell you? I told you 2 cycles are completed in 2 seconds. So in 1 second, how many cycles are completed? 1. So frequency will be 1. Are you able to understand? So the number of cycles completed per second by an alternating current is called frequency and is denoted by the symbol F. Right? So now again the question is, who is deciding the frequency of this? It is the same coil that we spoke about, because coil is the one which is going to decide the time period and the frequency. Right? Now, having said this, how are we going to derive an expression for frequency? We know the time period is equal to 1 divided by f, or f is equal to 1 divided by t. So we know that t is 2 pi by omega, so it will be omega by 2 pi. So it is going to be omega divided by 2 pi, which is given here. Right? So when I talk about an alternating current, it can be represented in the same format which I told you. I is equal to I naught sine omega t, or I naught sine 2 pi f into t, or I naught sine 2 pi into small t divided by capital T. That's the expression. Okay. And the next important point is, if you observe the frequency of alternating current that is used in our country, right, it is 50 hertz. So what is the meaning of this? The frequency of the alternating current that we are receiving at our home, right? All the devices work on alternating current only. The frequency of that alternating current is 50 hertz in India. If you look at US, right, it is going to be 60 hertz. So what is the meaning of this 50 hertz or 60 hertz? Means the coil which is generating this alternating EMF is completing 50 rotations in 1 second. So similarly, the generator used in US, the coil is there no in that part. That coil is completing 60 rotations in 1 second. That is the meaning of it. Are you able to understand this point? Right? In most of the questions, you will see this 50 hertz coming. So that is basically something related to our country. Is the point clear? Right? So this is all about the introduction of alternating current. So what did we see? We first tried to understand what is an alternating current. Then we saw what are all the terms that are associated with it. What were the 3 important terms we saw? Amplitude, time period, and frequency. But all these 3 are going to get related to one important EMF or current, which is called as the instantaneous EMF or instantaneous current. Is that clear? So this is the introduction. Make a quick note of it. Those are online. Am I clear?
Yes, sir.
Yeah.
Very good. So for today, we'll stop with this. The next class, I'll start with another important concept, which is called phasors and phasor diagram. Shall I end this? Did you all done? Are you all done talking? Okay. Okay. So can you come by 4 tomorrow? Tomorrow you have any special things? Tomorrow you'll be fine. Okay. Because it's an important topic I don't want to discuss. Okay. Yeah, ma'am. Those are online also you can learn that. Yeah, ma'am.
Thank you, sir.
Thank you.